In this video, we highlight use of the GeoViz Toolkit, an interactive exploratory spatial data analysis toolkit developed by Frank Hardisty in the GeoVISTA Center in Penn State University. GeoViz leverages and extends the library of open-source Java components in the GeoVISTA Studio component library, implemented in a flexible framework that allows analysts to quickly construct custom applications by mixing and matching components. The demonstration focuses on application of GeoViz Toolkit to analysis of data from the Google Flu Trends repository. The data consist of estimates of weekly percentages for influenza-like illness, or ILI, thus estimates of the fraction of patients who are experiencing influenza-like symptoms. The data cover flu seasons from 2002 through 2008. The initial interface contains 5 components. In the upper left is a variable picker with a list of weeks for which data are included. Next is a scatter plot where points are redundantly color-coded. The bivariate color scheme is also used in the choropleth map at the bottom right. A gray to blue range indicates low to high percent for the first week. A gray to red range indicates low to high percent for the second week. And relative similarity is indicated by the extent to which either color dominates, with the range from gray through purple indicating low low, medium medium, and high high percent for both weeks. The remaining 2 views are a histogram in the upper right that depicts values for a selected week, and a parallel coordinate plot, or PCP, in the lower left that represents trends by state across 6-week periods of time. Note the dramatic increase in week 2 of this period. The gray to red color scheme here is applied to data for a selected week. The red strings represent the states in the top 1/3 of ILI percentage that week, in this case, the first week. The video starts by showing an analyst exploring the data. By pointing to Indiana on the map, the state is highlighted and dynamic leader lines make it easy to see the position of the state's ILI percentage during week 1, its position in the middle of the scatterplot distributions comparing weeks 1 and 2 on the Y and X axes respectively, and the PCP time trend over several weeks. Examination of Illinois shows generally lower ILI percents and a flatter curve across the weeks. Clicking on points on the scatter plot allows the analyst to quickly determine where the extreme places are and what their ILI trend looks like. The extreme for week 2 is South Dakota. Pointing to one of the 2 high values for week 1 highlights Oklahoma. The X-centric labeling feature that shows labels for nearby places in the graph indicates that Nebraska was the other top value for that week. Selecting a group of the highest values for week 1 by drawing a box on the top of the scatter plot highlights those states with the highest percent ILI that week. The analyst then switches the comparison to week 1 versus week 3 in the scatterplot and map views and sets the histogram to depict the distribution for the 3rd week. Selecting top values for week 1 again, this time extending to a slightly lower percent threshold, highlights the contiguous block on the map as before, plus 2 Vanguard Eastern states. The histogram shows that most of the states in the top third for week 1 are in the lower half for week 3. Selecting high values for week 3 on the scatterplot shows a shift of ILI away from the west toward the southeast. Interestingly, West Virginia is no longer highlighted, indicating that it reached a peak in week 2 and rapidly declined. The PCP shows that these states include those that were the most extreme in week 2. The mostly red strings indicate that these states were already in the top third in week 1. The colors on the bivariate map show the dramatic shift from the blue states with a peak in week 1 but low ILI in week 3 toward the east. It also shows that this ILI outbreak appears to have bypassed Texas, Louisiana, and Florida, along with Oregon and New York, at least through week 3. Based on the Google estimates, this ILI episode appears to exhibit distinct spatial clustering that varies over time. To assess this, the analyst turns to the Moran map tool, a GeoViz component that calculates a local Moran's eye spatial autocorrelation measure. It allows the analyst to interactively examine which places are similar to or different from their neighbors. The first map and the histogram below it show the raw data, with county shaded red having an ILI percent in the top 1/3 and county shaded blue having an ILI percent in the bottom third. The second map and histogram show the local Moran's eye spatial autocorrelation values. Red represents high Moran's eye values, indicating similarity of a state to its neighbors, thus high near high or low near low. The third map and histogram show the observed pattern compared with 999 sets of random local Moran's eye values, reassigning the observed data to different counties and recalculating the values each time. This provides a measure of significance for local Moran's eye values. By clicking on the first bar of the histogram, all the maps have been filtered by Monte Carlo significance to only show counties that have higher local Moran's eye values than 95% of the random simulations, which indicates clustering. The fourth map and the scatter plot show the original values and the local Moran's eye scores in a bivariate map. The areas shaded in purple are high incidence and part of a significant cluster. For week 1, we see that the Great Plains Rocky Mountain cluster found in the previous view is significant. In map 1, it is also apparent that the New York, Vermont, Massachusetts cluster is significantly low in % ILI. When we switch to week 2, a pattern of transition is clearly evident. The Northwest now has a cluster of low values. South Dakota remains significantly high, but all its neighbors have dropped out of the cluster. A new cluster of high values has appeared in the Southeast, with Tennessee and the Carolinas. Finally, when we switch to week 3, we find a dramatic pattern. There is a large, significant cluster of low values stretching from Washington in the Northwest down through Texas. The Southeastern cluster has grown to include both Kentucky and Georgia. We welcome you to download the GeoViz Toolkit and try it out. It is available for free from the URL displayed. The software is written in Java and is open source. The source code is available from the Google Code repository at the link shown.